Hello everybody, today I'll be discussing thermodynamics. Thermodynamics is a branch of physics that deals with the study of energy, heat, work, and how they interrelate. It focuses on the principles governing the behavior of systems in terms of energy transfer and laws that describe these processes. What are some key concepts in thermodynamics? The first is system and surroundings. System is used to refer to the part of the universe under study, which can be open, closed, or isolated. Open system, that is, a system that can exchange both energy and matter with its surroundings. Closed system, a system that can exchange energy but not matter with its surroundings. Isolated system, a system that cannot exchange energy or matter with its surroundings. And then surroundings, that is everything outside the system that can interact with it. Next is state and process. A state refers to the condition of a system as described by its properties such as pressure, temperature, volume, and composition. Process is the transformation from one state to another. Let's quickly look at some laws of thermodynamics. The first is zeroth law, which states that if two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. The implication is that the law establishes the concept of temperature and thermal equilibrium. Next is the first law, also known as law of energy conservation, which states energy cannot be created or destroyed, but can only be transferred or converted from one form to another. Mathematically, it is U equals Q minus W, where U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. The second law states the total entropy of an isolated system can never decrease over time, and it reaches a maximum value at equilibrium. The implication of this is that it introduces the concept of entropy, a measure of disorder or randomness. It also implies that natural processes have a preferred direction of progression, that is, irreversibility. Next is the third law, which states that as the temperature of a system approaches absolute zero, the entropy of the system approaches a minimum value. The implication is that it is impossible to reach absolute zero in a finite number of steps. Other key concepts are heat, work, internal energy. Heat here is defined as the form of energy transfer between systems due to a temperature difference. Work is the energy transfer associated with a force acting through a distance, while internal energy is the total energy contained within a system, including kinetic and potential energy at the molecular level. Then enthalpy. Enthalpy is a measure of the total energy of a thermodynamic system, including internal energy and the energy required to displace the environment to make room for the system. We have also entropy, which is a measure of the disorder or randomness in a system. Applications of thermodynamics. In heat engines, it helps to analyze and design engines that convert heat into work, such as car engines and power plants. In refrigeration, it helps in designing systems that transfer heat from a cooler space to a warmer space, such as refrigerators and air conditioners. Then in chemical reactions, it helps in studying the energy changes involved in chemical processes. In material science, it helps in understanding the thermodynamic properties of materials to design new materials with desired properties. I'll be stopping here for now. Thanks for watching.